A beam ABC of length of 9 meter has one support of the left end and the other support at a distance of 6 meter from the left end, okay. Full point. The beam carries a point load of 1 kilonewton at right end and also carries UDL of 4 kilonewton per meter over a length of 3 meter as shown in figure. Okay. Taking E is equal to 2 into 10 power 5 Newton per mm square and I is equal to 5 into 10 power 8 mm to the power of 4. Determine the slope and deflection at point C. So the diagram is given in the problem. Write the diagram. So this is the diagram given in the problem only. Okay. So this is point A, B. This is point C and point D. Okay. Here in the question, you make a small change. 1 kilonewton is there, no? You make it 12 kilonewton. Make it 12 kilonewton. All of you go through the question. A beam ABC. Okay, ABC beam of length, total length is 9 meter. Okay, total length is 9 meter, has one support on the left end and other support is at a distance of 6 meter from the left end. Okay, support at B is 6 meter from the left end, means from support A, support B is at a distance of 6 meter. The beam carries a point load of 12 kilonewton at the right end and also carries a UDL of 4 kilonewton per meter over a length of 3 meter as shown in figure. Okay, from the right end towards left, 4 kilonewton per meter UDL is acting, correct? Young's modulus is given, moment of inertia is given. It is asked to find slope and deflection at point C, at the last point. Okay, solution, you write solution. First you find the reactions. Find the reactions first. Tell me the answer. Support reactions you find. Apply all the equilibrium conditions. Sigma fx equal to 0. Sigma fx equal to 0. There is no forces in next direction. Apply the next condition. Sigma fy is equal to 0. So here it will be RA, RB. Okay. Plus RA minus this UDL 4 kilonewton per meter. It is acting over a length of 3 meters. So minus 4 into 3 plus RB minus point load of 12 kilonewton is equal to 0. Therefore, RA plus RB is equal to how much? RA plus RB is equal to
0.
no, it is 24, no? 4 into 3, 12 minus 12 plus 24 on the RHS. Correct?
Yes, sir.
Take the next condition, that is sigma MA equal to 0. Moment about A equal to 0. You come from the 12 kilonewton force. 12 into total distance is 9 meter. And it will cause positive moment, clockwise moment, sign is plus. Then minus RB into 6 meter. This RB force will cause anti-clockwise moment about point A. Again plus moment of UDL about point A. First you convert UDL into point load, 4 into 3. Now it is converted into point load. Into perpendicular distance is from middle point of the UDL to the point A. It is 3 plus 1.5, 4.5 is equal to 0. Solve for RB now. What is the answer? Tell me. RB is equal to
Sir, RB is 27.
how much?
27.
Right. 27 kilonewton. RB is equal to 27 kilonewton. Then substitute RB in this equation. So 24 RA plus 27 is the RB value is equal to 24. Therefore, RA is equal to minus 3 you will get. Correct? Minus 3 kilonewton. 24 minus 27 minus 3. So here you write those reactions. RA we got it as minus 3 kilonewton. RB we got it as 27 kilonewton. Okay. Now this completes the calculation for reaction. Okay, support reaction. What next? We need to take the section XX. Where to take the section XX? On which span? Section XX. Girish, tell me the answer. Where to take the section XX? Girish, where to take the section? You need to take the section on the last span, that is section BC. Section XX at a distance X from the support A. Okay, below you can write a sentence. Consider a section XX at a distance X from left end or support A. Okay. Now next is, what is the next step after taking the section XX? You need to find the moment about section XX. Okay, you need to find the moment about the section XX. Here, all of listen here, whenever the UDL is given in the problem, the procedure is slightly different. See, whenever the UDL is given, for the remaining span here, so from D to B we have the UDL, no? D to B we have the UDL. This X, it may be here at this point, okay, at this point, or it may be here somewhere, okay. Therefore, what we have to do is to generalize the equation, to generalize the moment equation with respect to UDL, we need to add some dummy UDLs here. Okay, here you extend this UDL up to the full span. Okay, in upward direction, so in downward direction as well as in upward direction, in both the directions you apply the UDL. Are you understanding? See, if you are formulating the equation for moment for this UDL, to generalize the equation for the UDL, this UDL should be extended up to the end point. Okay. If X comes beyond the UDL point, no, then the generalized equation will not hold good if there is no UDL. That is why you need to extend the UDL up to the last point. So we are applying UDL, the same UDL of same magnitude of 4 kilonewton meter. 4 kilonewton per meter. Okay, from top as well as from bottom, equal and opposite. It is maintaining its equilibrium, no problem. But we are applying equal UDL of same magnitude, that is 4 kilonewton per meter through the full span. Okay. Here also you write 4 kilonewton per meter. Understanding? Remember this much. Whenever UDL is given, you need to extend the UDL up to the last point. This much you remember. Okay. Now you can formulate the equation for the mx. So mx is equal to mx, moment about x is equal to moment of this RA about section XX. RA into x plus RA into x. RA value is -3. -3 into x. -3 into x. -3x. Then moment of this whole UDL. This portion of UDL about the section XX. What is the moment of this whole portion of the UDL about the section XX? Huh? What is the length here? Length from here to here, students. I want length from here to here. How will find it? In terms of x. Huh? See here, the remaining distance is how much? Total from A to B, total length is 6 meter. Okay. D to B 3 meter. What is the distance between A and D? It is 3 meter. Correct. Distance between A and D is 3 meter. So the length of this UDL is x minus this 3. Are understanding? Length of the portion of UDL from point D to the section XX. You are taking moment of the portion of the UDL from the point D to the section XX. About the section XX, you are taking the moment. Okay. The intensity of the UDL is 4 kilonewton per meter. Okay, here I will write the intensity of the UDL. 4 into, it is acting over a length of how much? This length. This length is how much it is? It is x minus 3. X minus 3 will give the distance of the UDL between point D and the section XX. So it is acting over a length of x minus 3. Okay. Now you have converted UDL into point load. Intensity of the load is 4. It is acting over a length of x minus 3. Load into length will give conversion of UDL into point load. Again into perpendicular distance. Perpendicular distance means distance of the center point of the UDL from this section XX. Means x minus 3 by 2 into x minus 3 by 2. What about the sign plus or minus? Moment of this UDL about section XX. Moment of this portion of UDL about section XX. Positive or negative? Please reply. Kirtana. Positive moment or negative moment?
It's a negative.
Negative, correct. This UDL will cause the anti-clockwise moment. Okay, anti-clockwise moment about point C, this portion of UDL. So negative sign is negative. Okay. Now this whole UDL is over. Moment of this portion of UDL is over. Now we are left with this bottom UDL, which is applied in upward direction. You need to take moment of this upward UDL about the same section XX. Okay. In the same way, you find the moment of this UDL, whatever the method you followed for finding the moment of this top UDL about the section axis. No, same method you follow. First, you find the length of this UDL, distance from here to here. What is the distance from here to here? It will be x minus what? X minus the 6 meter. X minus 6. X minus 6. Okay. Now here intensity of UDL is 4 only. 4 into x minus 6 into x minus 6 by 2. What about the sign plus or minus now? Bonus rate. Moment of this upward UDL about point.
Clockwise direction, sir.
Clockwise sign is plus. Plus. Okay. And there is one more force that we need to consider for finding the moment, that reaction moment of this reaction about the section XX. What is the moment of reaction about the section XX? 27 into perpendicular distance is 3 meter, and it will also cause positive moment plus 27x plus 27x. Okay, this completes the moment about the section XX. Any doubts here, students? Any doubts in the calculation? One thing remember, whenever the UDL is given, you need to extend the UDL up to the last point. This is very important step. Okay, to generalize the equation for the full length of the beam, okay, we have to extend UDL up to the last point. Equal and opposite UDL of the same magnitude we need to apply. Okay.
Sir,
Yes.
27 x ಹೆಂಗೆ ಸರ್ ಅದು
27
x
27x ಹೆಂಗ್ ಬಂತಂದ್ವಾ ಹೆಂಗ್ ಬಂತು ಅಂತ ಕೇಳ್ತಾ ಇದೀಯಾ?
yes sir
It is not 27 into x, it is 27 into x minus 6. Okay, this distance is x minus 6 no. So reaction at B is 27. Perpendicular distance of section x is from the force is x minus 6. So here we change it to x minus 6. 27 into x minus 6. Okay. Now next step is same. We know that m is equal to EI into d square y by dx square. Therefore, from equation, both the equations we can equate EI into d square y by dx square is equal to minus 3x minus 4 into x minus 3 whole square by 2. So here we can cancel. Okay, you write one more step, no problem. Minus 4 into x minus 6 whole square by 2 plus 27 into x minus 6. Okay, you simplify this equation. EI into d square y by dx square is equal to minus 3x minus 2 into x minus 3 whole square minus 2 into x minus 6 whole square plus 27 into x minus 6. Okay. Now you have formulated the equation for the moment d square y by dx square. Now if you want to get equations for the slope and the deflection, you integrate now. Integrate with respect to x. Integrate with respect to x. So it will be EI into dy by dx is equal to minus 3x square by 2 minus 2 into x minus 3 whole cube by 3 minus 2 into x minus 6 whole cube by 3 plus 27 x minus 6 whole square by 2 plus C1. Okay, you can call this as equation number 1. This is the slope equation. To get the deflection, again integrate with respect to x. Integrate with respect to x again. It will be EI into y is equal to minus 3x cube by 6 minus 2 into x minus 3 to the power of 4 divided by 4 into 3. Correct? 4 into 3. Then minus 2 into x minus 6 to the power of 4 divided by 4 into 3 plus 27 into x minus 6 whole cube by 6 plus C1x plus C2. You simplify this, it will be minus x cube, 3 ones are 3 twos are minus x cube by 2 minus 2 ones are 2 twos are. So here x minus 3 to the power of 4 divided by 6. Correct? Minus here also 2 ones are 2 twos are x minus 6 to the power of 4 by 6 plus 27 by 6 is there. We can simplify this. 27 by 6. 3 9s are 3 2s are correct. It will be 9 into x minus 6 whole cube by 2 plus C1x plus C2. Call this as equation number 2. Okay. Now we have formulated the equation for the slope and the deflection. Equation 1 is the slope equation. Equation 2 is the deflection equation. But in both the equations, we have the constants C1 and C2. Now we have to determine the values of the constants. To determine the values of constants, we have to use what? Boundary conditions. Okay, at the shaded line, boundary conditions. Boundary conditions. What is the first boundary condition? For simply supported beam. Okay, wherever the simple supports are there, there is no deflection. Deflection will be 0. Okay, deflection of the beam will be 0. Okay, so at x equal to 0 means at support A, deflection is 0, which means that at x equal to 0, the deflection y equal to 0. First boundary condition. First boundary condition at x equal to 0, the corresponding deflection y equal to 0. Okay, we substitute x equal to 0 and y is equal to 0 in the equation 2. So in equation 2, if you substitute y equal to 0 and x equal to 0, 0 is equal to minus 0 minus 0 minus 3 to the power of 4 into 6 minus 0 minus 6 to the power of 4 by 6 plus 9 into 0 minus 6 to the power of 3 by 2 plus 0 plus C2. Okay, here you can see that 0 minus 3 means negative sign you are getting, negative, not applicable. If you are getting negative sign in the bracket, you should not consider it for calculation. Therefore, negative sign not applicable. Here also, negative sign not applicable. Only the C2 is remaining. That value of C2 will be equal to what? 0. Remember, always for simply supported beam, always you will get the value of C2, 0 only. Now go for the second boundary condition. Second boundary condition. Are you following, students? Are you following? Yes or no? Priya? Priya? Sunil? Sunil Yadav?
Sir,
Okay. Are you understanding? Are you understanding? Are you understanding the problem? I am asking, Sunil.
yes, sir.
Okay. Now at x equal to 6 meter. Here at 6 meter we have one more simple support. Means at x equal to 6 meter again deflection y equal to 0. That boundary condition you can utilize. At x is equal to 6 meter, corresponding deflection y is equal to 0. Okay, substitute x equal to 6 meter and y equal to 0 in the same equation too. So it is 0 is equal to x minus 6 q by 2 minus 6 minus 3 to the power of 4 by 2 minus 6 minus 6 to the power of 4 by 6 plus 9 into 6 minus 6 to the power of 3 by 2 plus C1 into 6 plus C2 value is 0. Okay. Now this becomes 0, 6 minus 6 becomes 0 here also. Okay. By this we'll get the value of C1. Tell me the answer quickly. What is the value of C1? Calculate the value of C1. Tell me the answer immediately after calculating.
Sir, 20.25.
Yes, 20.45. It will be 6 C1 is equal to 121.5 you will get. So C1 is equal to 20.45 you got I got 20.25, no problem. C1 is equal to 20.45.
Sir, 20.25, sir.
25 only, okay.
Yes, sir.
20.25. Okay, now you substitute the value of C1 and C2 in equation 1 and 2. So those equations will be equations for the slope and the deflection. Okay, below, right? Substitute the values of C1 and C2 in equation 1 and 2. So EI into dy by dx in equation 1. It is minus 3x square by 2 minus 3x square by 2 minus 2 into x minus 3 whole cube by 3. 2 into x minus 3 whole cube by 3. Then minus 2 into x minus 6 whole cube by 3. Minus 2 into x minus 6 whole cube by 3. Then plus 27 x minus 6 whole square by 2 plus 27 x minus 6 whole square by 2 plus C1 plus C1 means plus 20.25. We can call this as equation number 3, which is the equation for slope. So substitute C1 C2 value in equation 2 now. EI into y is equal to minus x cube by 2 minus x cube by 2 minus x minus 3 to the power of 4 by 6 minus x minus 6 to the power of 4 by 6 minus x minus 6 to the power of 4 by 6, then plus 9 into x minus 6 whole cube by 2 plus 9 into x minus 6 whole cube by 2 plus C1x plus 20.25 x plus C2 is 0. Call it as equation number 4. So these two equations are the equations for slope and the deflection. Now go to the question now. In the question, what is asked? To find slope and deflection at point C. Means at the end point we need to find slope and the deflection. Now you have the generalized equation for the slope and equation in terms of x. Now if you just substitute the value of x, okay, wherever you want to deflection in the slope, for that point, if you substitute the corresponding x value, you will get the slope and the deflection. Now it is in the problem, it is asked to find slope and deflection at point C. See, for point C, the value of x will be 9 meter. X is equal to 9 meter for point C. Correct? Now substitute x equal to 9 meter in slope equation and the deflection equation. You will get the slope and deflection at the point C. Okay. First you write slope at point C. Slope at point C. Point C means for C the x value is 9 meter. The distance of C from the starting point is 9 meter. Substitute x equal to 9 meter in the slope equation. Substitute x is equal to 9 meter in equation 3. So you will get the slope. So EI into dy by dx at C, slope at C is equal to minus 3 into 9 square by 2 minus 2 into 9 minus 3 whole cube by 3 minus 2 into x minus 6 whole cube by 3 plus 27 into x means 9, no? 9 minus 6 whole cube by 3, 27 into 9 minus 6 whole square by 2 plus 20.25. Find the value here. Find the value. So EI into dy by dx, I will call it as theta. It is nothing but dy by dx is nothing but slope at c, theta c. I will take it as theta c is equal to so I got minus 105.75. Check the answer. Check the answer. So here unit will be E into I is there on the LHS, which is equal to kilonewton per meter square into meter to the power of 4. Finally, you'll get kilonewton meter square unit for the RHS value. Okay, kilonewton meter square. Because the loads are given in terms of kilonewton, distances are given in terms of meter square, the unit will be kilonewton meter square. But E and I are in terms of Newton per Newton mm, Newton and the mm. So convert this kilonewton meter square into Newton mm square. Minus 105.75 into 1 kilonewton is equal to 10 power 3 Newton into 1 meter is equal to 10 power 3 millimeter square. So it will be minus 105.75 into 10 power 6 plus 3, 9 Newton millimeter square. Therefore, theta c is equal to minus 105.75 into 10 power 9 whole divided by E into I. Therefore, theta c is equal to minus 105.75 into 10 power 9 divided by substitute the values of E and I. E is 2 into 10 power 5. I is 5 into 10 power 8. 2 into 10 power 5 into 5 into 10 power 8. Therefore, theta c is equal to tell me the answer, theta c. Kirtana, tell me the answer, Bhuvanasri.
So minus 1.05 into 10 power minus 3.
Minus 2, huh? So I have minus 5 over here. Once again, you calculate. Minus 2 you are getting. Minus 5 or minus 2 it is. Kirtana, what is the answer?
So minus 1.05 into 10 to the power of minus 3, sir.
Minus 3 you are getting.
Yes, sir.
2 into 10 power 5. What about Bhuvanasri? You are also getting 10 power minus 3 only?
Yes, sir. 10 power minus 3.
Okay, whatever the answer you get, you take it. Minus 3 radians. Now to find the deflection at point C, substitute x equal to 9 meter in the deflection equation now. EI into y. Okay, so EI into y is equal to EI into deflection at C you are finding is equal to YC is equal to minus x cube by 2 minus 9 cube by 2 minus 9 cube by 2 minus of x minus 3 to the power of 4 minus divided by 6. 9 minus 4, sorry, 9 minus 3, 9 minus 3 to the power of 4 by 6 minus 9 minus 6 to the power of 4 by 6. by 6. Then plus 9 into 9 minus 6 cube by 2. By 2 plus 27. Sorry, plus 20.25 x plus 20.25 x means 9 meter plus 0. So EI into YC is equal to, what is the answer? Tell me on the RHS. Immediately tell me the answer after calculating. Are you getting this answer? Check it out. Are you getting this answer?
No, sir.
Huh?
No,
Not
sir.
getting?
No, sir.
What is
438.75.
438.75? Ah?
Sir.
Who is getting that answer? Kirtana. Bhuvasri, what about you?
Sir, I'm solving, sir.
Huh?
Sir, I'm
How much?
solving the 1 second, sir.
Okay.
Sir, sorry, sir. I got minus 290.25.
Minus 290, yeah?
Yes, sir. Yes, sir.
Okay, we'll cross check with one more person. Anyone please calculate and
Minus
tell your answer.
263.25.
Huh?
Minus 263.25, sir.
Minus 263.25 kilonewton meter cube. Okay. So kilonewton meter cube means here it is unit, as I told, EI into Y is there. Kilonewton per meter square into meter to the power of 4 into meter. If you simplify, finally it will be kilonewton meter cube. Okay. If you need to convert this into Newton millimeter cube. Minus 263.25 into 1 kilonewton is equal to 10 power 3 Newton into 10 power 3 millimeter cube. So it will be minus 263.25 into 10 power 12 Newton millimeter cube. Therefore, YC is equal to minus 263.25 into 10 power 12 divided by E into I. Substitute the value of E and I. 263.25 into 10 power 12 divided by E is 2 into 10 power 5 and moment of inertia is 5 into 10 power 8.
So minus 2.6325.
Minus 2.6325, right? So deflection at C is minus 2.6325 millimeter. Downward deflection. Negative sign represents downward deflection. This is deflection at C. Okay. Theta C is equal to 1 into 10 power minus 3 radians. If you want, you can convert it into degrees by multiplying by 180 by pi. Okay, so this completes the problem. We will stop to here and we will continue the next class.